Good morning. Good morning. We're going to get started here. So today we're going to do some practice with section 10.2, differences between two population or group means. To start, I'm going to do an example problem, and then I'm going to give you guys a problem to work on yourselves. See where we're at after those two things happen, and we'll go from there. All right, so it'll be a little different than yesterday. And, we'll see how that goes. So to start, let's do this. All right. Share my screen. Done. Alrighty. Pardon me. So we're going to start by looking through an example problem. All right. So in a study of heart surgery, one issue was the effect of drugs called beta blockers on the pulse rate of patients during surgery. The available subjects were divided at random. Right, that's kind of interesting. Delete that. That is far too large of a highlight. That's probably going to be better. That's better. Into two groups of 30 patients each. One group received a beta blocker, the other group received a placebo. The pulse rate of each patient at a critical point during the operation was recorded. The treatment group had a mean pulse rate of 65.2 and a standard deviation of 7.8. For the control group, people who got the placebo, the mean pulse rate was 70.3 and the standard deviation was 8.3. So in our context here, we have a few things to highlight, obviously, that have been highlighted. Right here, the 30 patients each. That gives us the sample size from both populations. Right, this 30 here, that it will be N1 and N2. So that's good to know. We have our two groups. All right, the treatments were essentially randomly assigned, so that's going to be good later. In the treatment group, the ones who got the beta blockers, we have a mean pulse rate of 65.2. That will be our X bar 1. Standard deviation of 7.8. S sub 1. The mean pulse rate for the control group, we'll call that X bar 2. And the standard deviation was 8.3. S2. All right, so we have used our context here. We've identified the key values that we're going to need. We've highlighted a couple of things here. So now we're ready to move on to answer parts of the question. Part A says find the standard error. The standard error is basically the adjusted standard deviation based on the fact that we're using a sample, right, and not the actual standard deviation. Right, we're not doing the entire population calculation here. We're just using these sample statistics that we have. Right, so the standard error notation is this big old chunk of stuff right here. Right, this right here is not telling us that that's not a calculation. I don't need this to do x1 minus x2 here. Right, this is just notation saying I'm going to find the standard error of x bar 1 minus x bar 2, the difference of the two sample means. The calculation is what's in the square root over here. All right, so again, we have our square root of the variance from sample 1 divided by the size of sample 1 plus the variance of sample 2 divided by the size of sample 2. Right, and we substitute in all our values. Right, our 7.8 from the treatment group goes to being 7.8 squared divided by 30 plus 8.3. The standard deviation from the control group squared divided by 30. All in all, we get an approximate answer of 2.08 as our standard error. We'll need that later. It is important to remember to square the two standard deviations that you have, the 7.8 and the 8.3. We need to square them because we're using variance. We're not just using the standard deviation value. Is there anything I can clarify so far on this example? So then that leads us to the next part of the question, part B. We need to construct and interpret a 99% confidence interval for the difference in mean pulse rates. That means we need to use our 4-step process. We've been asked to construct and interpret, that is doing inference. That means 4 steps. The first step is our statement. We want to estimate with 99% confidence the difference mu1 minus mu2, where mu1 is the true mean pulse rate of patients similar to those in the experiment who take beta blockers, and mu2 equals the true mean pulse rate of patients similar to those not taking beta blockers or the ones that took the placebo. That is our statement. We are including phrasing in here that says that because mu, right, that's a population mean. The only population we can do inference on is the population of patients similar to those in the experiment. So that is part of how we're defining our variable. Right, because these patients were not randomly selected, they are from the patients that were available, right, the available subjects. Right, we cannot perform inference about the larger population of interest. We can only do an inference about the population similar to the patients that were in the experiment. So we need to make sure and be clear about that. Next, we must do our planning step. If conditions are met, we will use a 2-sample t interval for mu1 minus mu2. Again, the t interval is used when we're dealing with sample means. Is our t distribution. We use table B, all that fun stuff. Randomness. The 2 groups were randomly assigned to a treatment. Randomness has been fulfilled. 10%. Since we are not sampling, we did not randomly sample these people from the population, this condition is not needed. Right, we did not sample without replacement. 10% condition does not need to be confirmed. Then we have a normal large sample. Both sample sizes are at least 30. They are 30, that is at least 30. So the normal condition is met. We are now free to use our t procedures. And that's a good thing. Is there anything I can clarify about the planning step? That then leads us to doing some calculations. All right, this highlighted thing here is the formula that we're using. This is the formula that gives us the interval. We use the difference between the, we're using the difference between the 2 sample means plus or minus the critical value times the standard error. Right, the difference of the 2 means is our test statistic. Right, and this formula is essentially the general formula we use when creating intervals, test statistic plus or minus critical value times standard error. So when we substitute in values here, first 99% confidence using table B with degrees of freedom equaling 29, because both sample sizes are the same. Both sample sizes give us a degree of freedom 29. There is nothing lower, right? Because remember, when we have the 2 samples and we're comparing the 2 means and finding the difference between 2 means, we use whichever degree of freedom is smaller between the 2 sample sizes. In this case, it is the same, so we don't really have to worry about that. Using table B, that leads us to a critical value of 2.756. Right. And so that's what we use for our critical value over here. We get 65.2 minus 70.3 plus or minus 2.756 times 2.08, which is what we already calculated in part A. Right? We actually already found the standard error. There's no need to recalculate it. We did it earlier in the problem. We can just use it. That equals negative 5.10 plus or minus 5.73 approximately. And then we get this interval, negative 10.64 comma 0.44. Right. And once again, I want to highlight the fact that the smaller number is listed first in an interval. Please ensure that you're writing the smaller number first, larger number second. Right, so our interval is from negative 10.64 to 0.44. Is there any questions or anything I can clarify about the calculations? And then that allows us to make our conclusion. We are 99% confident that the interval from negative 10.64 to 0.44 captures the true difference in the mean pulse rates of patients receiving beta blockers during surgery and those who take a placebo. All right. And that's our conclusion about the confidence interval. Any questions?
You got 2.756 from table B, right?
Correct.
Okay, thank you.
Would you like to see table B and how we got that, or do you understand how we got there?
If you can go through it, please.
I can do that. You get mid table. All right. Oh, I actually have the writing on here from previous class. So on table B, we find our confidence interval, so to say, along the bottom here. So we find 99%. We find 29 for the degrees of freedom. We find the intersection of those two, and that is our 2.756. Later on the next part of the problem here, we'll see why there's other marks on this table B for using significance testing.
Okay, thank you.
You're welcome. All right, so part C here, suppose we want to test the hypothesis that beta blockers reduce mean pulse rate. State the null and alternative hypothesis for this test. So we have a null hypothesis that there is no difference. Mu1 minus mu2 is equal to 0. And we're using the same mu1 and mu2 that we previously defined in part B. All right, since it's already been defined, we can use it. We're talking about the same problem with the same context. If you want to be extra sure, you can say that mu1 and mu2 are defined the same as in part A or part B, and that will suffice as well. And then our alternative is that mu1 minus mu2 is less than 0. This again is because of how we define them. Mu1 is for the people who got the beta blocker, mu2 is the people who did not. So if mu1 is less than, it's a reduced pulse rate, it's a smaller number. When I subtract a larger number from a smaller number, I get a negative number, which means that value should be less than 0. So that's how this inequality is determined here. Is there anything clarify about our hypotheses? So then part D, the test statistic is t equals negative 2.453. We want to determine the p-value and draw an appropriate conclusion using alpha equals 0.05. So in this case, we were never asked to conduct a significance test. All right, we were asked to identify our hypotheses, and then we were given the test statistic value and the alpha to use. Now we're essentially just jumping to the conclusion. Find the p-value, make a conclusion. So with this t statistic and using degrees of freedom equaling 29, we'll end up getting a p-value that is between 0.01 and 0.02. Again, I said we'll refer back to table B here. 29 degrees of freedom. We get the t-value required is between 2.15 and 2.462. Right? Because again, it was 2.453. That's somewhere between these two numbers, which means our p-value is somewhere between these two numbers of 0.02 and 0.01. And again, when we write that interval, or we write that inequality, we always write the smaller value first. So we get 0.01 is less than p-value is less than 0.02. Since 0.02 is definitely less than 0.05, the p-value is less than alpha. Right, so since the p-value is less than alpha equaling 0.05, we reject the null hypothesis. We have convincing evidence that beta blockers reduce mean pulse rate among patients similar to those in the experiment. Once again, my conclusion I can only perform inference about those similar to the ones who participated in the study, because we didn't randomly choose our subjects. Is there anything else I can clarify? Are there any questions? All right, so then what we're going to do next is we have a practice problem for you all to do that is very similar to the one that I just did. It's going to have the same 4 parts. I'm going to drop a link into the chat. That takes you to this practice problem. It does reside within Canvas. It is labeled as an assignment, but it is a practice problem, and I'll tell you what I expect you to do with that momentarily. So let's get there and let's do that. And I'll share my screen again to show you what's going on. All right, so you should, if you click on that link, get to a page that looks very similar to this one, as this is the student view. It should be what you guys are seeing if you click the link. All right, so I've done the example problem. All right, so we're gonna solve this following problem. I would like you to do your work on paper and then upload a picture of your work. I find that this is much easier as far as like taking a picture and uploading it if you have the Canvas student app, because then it's kind of like sending a text message. You can go into the app and the assignment and actually just like take the picture within the app and it goes right in there. So that's just an offer. You do not have to do it that way if you do not want to. All right. If you would like to collaborate and work with another classmate here, please let me know and I can put you guys in a breakout room and you can work together. However, again, I do want you to do work on paper and you'll be able to upload a picture of your work. Make sure to identify all necessary methods, parameters, and conditions. You should always be using the 4-step process to perform any inference. We have some resources here. There's a link to the 10.2 study guide, similar to the link to the 10.1 study guide we used yesterday, and also, again, the formula sheet and tables. Okay, so here is our question. Right, Jordan's cat Fern is a finicky eater. Jordan is trying to determine which of two brands of canned cat food Fern prefers, Tabbycat or Chow Lion. For 2 months, she flips a coin each day to decide which of the two foods to feed Fern and weighs how much Fern eats in grams. Here's the data. Right, so we got a little table here that shows us the sample size for each food, our sample means, and sample standard deviation. Right. Just like in the last problem, you need to find the standard error for the difference. We need to construct and interpret a 99% confidence interval, and then we need to write some hypotheses and determine the p-value and draw an appropriate conclusion based on the provided t statistic or t-value. All right. So essentially the same steps that we're doing here. If you'd like to refer back to the example problem that we just saw, that is linked in the Canvas module, where this assignment is also housed within the Chapter 10 module. The example problem is a little PDF that is right underneath this assignment. Is there any questions? Anything I can clarify? All right, so just like yesterday, I'm going to give you guys a set amount of time to work on this. We're going to go with 20 minutes to do work on this, and when that time is up, we'll talk to you again about what I want you to do next. All right, so where is my timer? It's over there. Find my 20-minute timer somewhere around here. There it is. All right, so we're gonna get the timer going. If you have any questions while you're working, please feel free to drop them in the chat. I'm happy to help, or just unmute your mic and ask. And we'll reconvene in about 20 minutes. Okay, so that was 20 minutes. So that may or may not have been enough time for you to work through all parts of this problem, and whatever it is that you got done, that is okay. What I would like for you to do is whatever you do have completed at this point, please submit that for this assignment. This does not need to be completed to get credit. This is your participation essentially for today. Whatever you have done is perfect. I just want to see what that is. So please submit whatever you've completed, whether that's just part A and part B, only part of a part, right? Or if you were going through the study guide and taking notes and that was all you were able to get to, that's totally okay too. Please mention that. You could use, if that was all you're able to do, please just use the text entry option for your submission type and state that that's what you were doing. Is there any questions about what I'd like you to do here? So again, I'm not concerned about whether or not you're able to finish the problem at this point. I want you to know what 20 minutes feels like while you're working on this type of free response question, and become more aware of time. Next week, we will be spending one more day wrapping up Chapter 10. And so then the Chapter 10 assessments will become available between now and the next time I see you. And the other day that we meet next week will be used on AP exam prep things. So going through some things about making sure you are ready to digitally take the AP exam. This will also consist of taking a shortened practice exam that will take, it'll be a little bit longer for us to meet, but it'll take a little bit over an hour depending on how everything shakes out. Okay, so that will be next week as well. And it'll be a good opportunity for you to feel what the AP exam will feel like, the timing, how the test interface works and all that stuff. That is why we're doing it. All right. And besides that, that is all that I have for you today. If you have any questions, comments, concerns, you need help on anything, please, again, make sure you reach out to me, let me know. You're welcome to stick around after this and ask. And I will see you next week.